Hello, and welcome to another episode of Teaching with Monthly Learning. Today we're going to do something a little different. We're going to look at how simple everyday materials can make a huge impact on your science classroom. So I decided to show you how this can be done using my own family and my new unit on the properties and mechanisms of flight to be released on April 5th, 2021. We've put together some great hands-on learning tasks in this unit, but I don't want to scare you to think that experiments need to be complicated or that you don't currently have much to support your science program. These experiments are out of the question. Many simple, low-prep science experiments can be done using common materials found at home, materials that you ask for donations, or a small, inexpensive trip to the dollar store. Often, that trip can easily be funded by your principal out of their petty cash just using the school credit card. So first off, I told my kids that we were going to have an experiment day. To say they were excited was a bit of an understatement. The excitement was actually pretty unreal. This is typical for the excitement that happens in your actual classroom when it's time for experiments to happen. Why? Well, because they're fun. And when you tie it back to the learning that's supposed to happen inside these experiments can be super impactful. And you definitely need both of those parts for the learning to happen. You need the experience, and then you also need to tie it into the learning. So off to the dollar store we went. Loaded 3 kids in the car and off to the dollar store. And I promise I didn't buy all of the markers and pens, but I bought quite a few. Really, many of the things that I did buy, I would typically have had in my classroom, such as rulers, paper, or even plasticine or Play-Doh. But I picked these up because they're not easily found in my house. And after the supply monsters are let loose in the stationery supply, I got nothing left anymore. The key to many of these experiments were balloons. Balloons are so universal, they come in packs of 20 or 30, so they can be used really easily, and it's easy for kids to do. Once we returned home and I was finished setting up all the recording equipment so that I was able to actually capture this footage for this video, we were finally ready to begin. The first experiments that we started with required 2 pop bottles. We actually used Perrier bottles because that's what we had, and we stretched the balloon over the neck of the bottle and then pushed the balloon inside the bottle. The purpose of this experiment was to demonstrate that air takes up space. I told my kids to blow into the balloon, and they thought they were superheroes and would be able to blow it up, even though it was inside the bottle. However, they were quite surprised that despite their valiant effort, the balloon only blew up so much. I asked them if air takes up space, and they agreed that it did. And then they were able to tell me that they couldn't blow up the balloon because there was already air in the bottle, and it was restricting the amount of space the balloon had to expand. So I asked them if there was air in the bottle, would it blow up the balloon? We squeezed the bottle, and the balloon popped out of the bottle, and the balloon popped out of the bottle and inflated slightly. This is the exact learning that I would hope to see my students have from this simple experiment. It's not complicated, it takes up very little materials, and accomplishes a great deal. You don't need pre-made science kits or an expert in air mechanics to see this. My 7 and 10-year-old can see how this works simply and easily, and so can our grade 6 students too. For our next experiment, we looked at how strong is air pressure. And for this, we simply needed a ruler, which almost every classroom has, and a newspaper. However, I would recommend not using the flexible ruler like the one I used. For this, we're really looking at the fact that air is putting pressure down on the newspaper. So when we put the newspaper on top of the ruler and then we hit the ruler, we're going to notice that the ruler, when it's not flexible, is going to have a harder time lifting that newspaper. And this is a very simple experiment that can be done in the classroom because we have tabletops, countertops, or desks, and we have rulers, and we probably have a whole lot of paper. Or we can simply bring a newspaper from home. So simple experiment, simple materials, really easily accomplished in the class. Now, the next experiment was a favorite, and it was making a balloon scale. This required 2 balloons, a ruler, some tape, some string, and a place that you could suspend the scale from. I suspended it from a light, but you could suspend it from a gap between 2 tables or anything that you really have in your classroom. Now, the reason that this was a favorite was because, number 1, it looks pretty neat, and number 2, it really does show the property of air that is being demonstrated here. Does air have weight? Students understand what a pan balance is, and they understand scale, and that when something something is of equal weight, they are balanced between the two sides. So while you attach the balloons to either side of the ruler and you suspend the ruler from the string and you balance your scale so that both balloons are balanced and the ruler is sitting right in the center and it's stable. But then you cut a hole in one of the balloons, and as you do this, the scale quickly becomes unbalanced, and students see that when there is unbalance, that means that the only thing that changed was that the air in the one balloon escaped. So they begin to understand that air does have weight, and that without equal amounts of air in either side of the balloons, we don't have balance. So therefore, because there's no balance, there must mean that air has weight. And you can go ahead and cut the air out of the other balloon and then rebalance the scale. Students will see that the balloons have stayed constant. The scale still remains balanced. It's not a broken scale. The only difference is that both sides must have equal amounts of air in order to stay balanced. In the next experiment, it helps us to show the power of air when it's under compression. Air under compression can hold weight and can help us lift things, and it's also why we use air to fill our car, bikes, and tires. In this experiment, we are going to use balloons or a Ziploc bag with a straw taped into it to simulate an airbag. Without the air under pressure, we will not be able to lift these books. However, with the air contained inside the balloon or baggie, we will be able to use that compressed air that we blow inside the bag to lift up the books. In your classroom, you can use much heavier math textbooks to show this property of air. In a classroom setting that is at a constant altitude, it would be more difficult to show how altitude and atmospheric air pressure is measured. With this experiment, students will create their own barometer. Now, not all experiments are designed to be something that each individual student can do. This particular experiment is a bit more complex, so it might lend itself better to a teacher-led demonstration, to a whole class or to a small group, or could even be done by larger groups of students when done together. This does require a few more materials, but many of them can be found from your own recycling bin, items in your classroom, or within your school or within your home. You will need 2 containers, one that will comfortably fit inside the other with about 1 inch or 2 of room between the walls of the 2 containers. First, you will make your barometer. To do this, you will stretch the smooth part of the balloon over the mouth of the jar and glue a flat toothpick or straw onto the center of the stretched balloon and let dry, making sure that toothpick overhangs the side of the jar about 1 inch. As the air pressure changes, the toothpick will move up and down. This will allow you to track the air pressure. Now, these movements will be slight, so it's important to track its movement over many, many days. This will be enough for you to measure the change in air pressure over time as it fluctuates day to day. However, to simulate how air is impacted at different altitudes and under different air pressures, you will need to put the smaller jar into the larger one to create the ability to measure different air pressures. By stretching the mouth of a second balloon over the larger jar, making sure that the part you blow into is kind of sticking out up the top, and then grabbing onto that part of the balloon and pulling it out and pushing it in, you will begin to see the toothpick on the smaller jar move up and down. This will help your students see how air pressure is different at different altitudes. Now, we can't talk about flight if we don't talk about paper airplanes, right? This experiment has easy and ready-to-use materials and the competition students love. Challenge your students to try out different methods of building different types of paper airplanes. Use helpful instructional YouTube videos to create these variations of the traditional airplane model, and then challenge them to go further and create their own airplane design or new ways to construct this with only one paper and some creative paper folding. Then take your students outside and have them throw their creations. Monitor how they fly. Have the students hypothesize which plane flew the furthest, which plane flew most straight, and any other criteria that your students want to track. And then have them identify how the different designs help their plane to fly better than others. Experiments are supposed to be fun and engaging, and they can also be simple to do and easy for any classroom. Now that you have all your materials for this experiment and all of the other experiments you've done for this unit, it's time for you to clean it all up. Now the fun part, right? Well, first, get your students definitely to help you, but I also really like to create buckets of experiments. This is going to save you a lot of time next year or any other time you need to do this experiment again. Now you have ready-made experiment kits. I really like the plastic containers, and I'm loving the 12 by 12 plastic scrapbook bins from craft stores to store all of your experiment materials. First, wash and sanitize any of the materials that you need to simply keep enough for you to use as a demonstration the next time. Number 2, save all of the experiment pages inside that bin. Sort them in an envelope if needed by different type of experiment, but include things like instruction pages, recording pages, centers cards, reflection pages, assessment exit slips, or even the lesson plan. Add all of the materials that can be reused like string and rulers to the bin. Try not to throw anything out if it's possible to reuse it. Then add any unused materials that you didn't use or that you bought excess of into the bin. Really, add as much as you can so this kit is grab and go ready the next time you teach this experiment. Put it all together and safely store it somewhere in your classroom for next time. While it took you a while the first time to bring everything together and put it all together, because you've made this kit, the next time you do this experiment, it's not going to take you so long.
Thank you for listening to the Teaching with Madly Learning podcast replay. Join me on www.madlylearning.com for more information on all things teaching in the junior grades. Don't forget, you can always catch this show on the Madly Learning YouTube channel. See you next week for another replay episode of Teaching with Madly Learning.